There's an object-oriented programming principle that says program to interfaces, not implementations. And the idea there is that you couple two classes together whenever you use the new keyword. There's a phrase, new is glue. And the idea there is that if one class creates a new instance of another class, those classes are now tightly bound together. And the problem is it's difficult to break that binding when you want to do things like isolating the class to unit test it or to use it in a whole different context. Instead, what you should do is define an interface and reverse the dependencies. Instead of class A creating an instance of class B should implement a contract, implement an interface, and then class A says, I don't care who you are, I don't care what you do, all I know is that for me to function, somebody has to pass me a instance of a class that implements this contract. So class A says, here's a contract, this is the contract with the methods that I expect a class to implement in order for me to function. And now you can create a number of different, you can create class B and C and D, as long as any of them implement the contract, the interface, then you can pass it to A. And so in doing so, you have inverted the dependencies. Instead of class A depending on class B, class A depends on an interface, class B implements the interface, and you can pass B into A, or C into A, or D into A. Okay? So that is the inversion of control, or IOC principle in software development. It's also called dependency injection, where I have a dependency, I need somebody to inject it into me. And the ASP.NET MVC Core framework has implemented dependency injection in its own way by default to enable scenarios like unit testing so that a controller class can say, I have a dependency. I need some way to save data into a database. So I'll say I need an application DB context. I don't care who you are, I just need one passed into me. And so the dependency injection framework inside of ASP.NET MVC Core already knows about the application DB context. It already created an instance of it. It has it available, and it gives an instance of that application DB context to my controller in the constructor, saves off that reference into a private member variable, which it can then use from that point on in every one of the methods. Okay, so this is kind of a little bit of an advanced topic, but you're going to need to know it. If you see a constructor and it has an input parameter, 99% chance it's expecting the dependency injection system in ASP.NET Core to pass it to that. Now, where does ASP.NET Core figure out what an application DB context is, and how to create a new instance of it, how to give it to any controller that asks for it? Well, that happens in the startup.cs. There's actually something called configure services. And so the services, you can see that this method gets called by the runtime. Use this method to add services to the container. Those services then are part of that dependency injection framework. Those services get passed to each of the controllers as they have need. So in this line number 43, we're saying we need to add a DB context to this service framework. We give it the type, the specific type, application DB context, because that was generated automatically for us. See, this is where we added our code. Let's get back, hitting Control minus. All right, and saying, hey, when you create an instance of this application DB context and create a new instance of it, we want you to use SQL Server with this connection string like we just talked about, right? So it creates a new instance of the application DB context. That context knows where it needs to access the data as we run it right now on our local computer or in the cloud or in some other server environment. And now every time one of the controllers needs access to the database, it just says, hey, I need application DB context. You got one for me? Oh, yeah, great. So the beauty of this now is that I can create unit tests that isolate each of the individual methods in my to-dos controller. I would pass in a fake version of application DB context, and then I would say, hey, fake version, at any point while running, let's say, the details method, was your single or default method ever called? If so, if it ever gets called, give it back this fake instance of the model, okay? And then we're going to watch what it does with that fake instance, because we can control now what the data looks like that we return back. We can monitor whether anything has changed about that method since the last time we made changes inside of our application. So that's kind of the thought process. A little bit advanced. I tell you what, we'll get into that and we'll show some examples of how to unit test these simple CRUD style methods at some point in another micro course. But the long and short of it is this. You're not going to get very far in ASP.NET MVC Core without understanding that you're going to need, probably at a minimum, you're going to need this application DB context passed into every one of the controller classes that you create. Now, some classes have additional needs. If we take a look at the account controller is what handles things like login, registration, forgot my password, lockout for too many incorrect login attempts, and so on. It needs a lot of different things. Now, some of those things it needs have a dependency on the entity framework. You just don't see it here. Things like the user manager and sign-in manager. But you can see here in the constructor for this account controller that it needs all of this stuff. Some of it will be obvious to you, and I can point it out to you, and some of it may not be quite as obvious. It's not set up in just exactly the same way as the DB context was. And generally, you never have to touch it in the startup.cs file. So, at any rate, it needs a user manager. This is the class that manages the users tables in our database that uses those individual accounts. So, if we were to take a look at this, all of these tables right here support ASP.NET Identity. That's what gives us the ability to log in and give roles to individual users in our system. All right, so we'll spend a whole micro course on ASP.NET Identity. I don't want to get into it just yet, but this user manager class is created by ASP.NET MVC Core, and it gives us access to those tables through a friendly set of methods like login, get user, get users, get the role for this user, and so on. There's the sign-in manager. I guess that's the one that actually does the login, sorry, but it has that very specific purpose. Options related to cookies, so when somebody logs in, they'll get a cookie come back to their hard drive on the next get, and it will have their role and their ID and everything encoded in that cookie, and this just gives us access to those values that are in the cookie for login purposes, like remember me, that little checkbox in the login. Here's email sender and SMS sender. So if you have two-factor authentication, or anytime you need to, like a forgot password, I want it to send me an email with a link that I can click on to reset my password. It just validates that you, in fact, own this email address. It's the email address that you set up whenever we started created an account for you. So we need something that implements the email sender interface. We're going to go off and create custom code to do that, or SMS to give you that code that you can type in. We might use something like Twilio, for example, a third-party service that handles that, or SendGrid that would handle the email sender side of things. And we'll create that in another micro course. Logger Factory, logging out to files, logging out to screen. We want to output things to the logger, so we need that. Whatever the logger is, give it to me, because I'm going to use it in the course of all the methods in the rest of this controller. All right, so you see, all account controller is doing is saying, it makes a laundry list of things it knows it's going to need at some point. I need this, I need that, I need this, I need that. I don't care how you give it to me, give it to me. Now, in most cases, this is all going to be set up in the startup, and it actually happens in these lines of code here that I don't want to get into in the moment. But if I'm ever unit testing this code, then I can fake each of those classes, and then I can watch how they're being used, using my, my unit testing framework and my faking or stubbing framework, okay? So don't want to get into too much deeper than that. Just understand that whenever you need a database connection, just say, hey, I need a application DB context, give it to me, store off a local version of that variable, and then use it in the remainder of the methods in that class, okay? So we're getting close to the end of the things that I want to talk about in this absolute basics course. We're going a little bit beyond that, honestly. I'm going to do a little brainstorming and think if we've covered all the basics, and then we'll wrap up this course. Told you it would be short. Hopefully it's helpful. We'll see you in the next video. Thanks.